Hey everyone, and welcome to a new topic. Today we're going to be starting our topic of equations from the Year 8 syllabus in Australia, where I'm from. And because a lot of the material from this is stuff we covered in the Year 7 course, this idea of solving equations with brackets, with fractions, the technique of solving these systematically, coming up with this system for solving equations. I'm not going to touch on that so much here. I'm going to say that that's assumed knowledge. So if any of the ideas here are a little bit confusing and maybe unfamiliar to you, I would say to redirect yourself to the Year 7 playlist for solving equations, because that will give you a nice, thorough glimpse into the idea of solving equations. Here in this video series, I just want to address the new things that we are going to be touching on. And in this introductory video, I just want to give you another interpretation of solving equations. Now you can see here I've written as a heading, solving equations scale analogy. And underneath I've drawn this little old school measuring scale. If some of you may have seen these, maybe when you go to the supermarket. But this is a scale which has two measuring things on each side. So if this scale is perfectly balanced, it means that whatever I have on the left-hand side is equal to whatever I have on the right-hand side. This is a feature of equations. We need to have an equal sign, if you remember that. It's just a mathematical truth that shows that the left-hand side equals the right-hand side. And what we were doing throughout equations was this idea of finding these unknowns that make an equation true. And in doing that, we solve the equation. So I want to start off with this analogy and a couple of revision questions, some revision ideas that we talked about before. And then I'm going to slowly bring you into introducing the first new topic here, which is equations with pronumerals on both sides, which I will go into a lot deeper in the next video. But this one's really just to give you an idea, another interpretation about how equations work here. So picture this measuring scale here, and I'm going to say that I have a bag full of marbles. I'll call that B. And I have another one, two marbles here. And I have 1, 2, 3, 4, 5 marbles on this side. So I basically want to find, well, how many marbles are in this bag? Let's call that B. That results in this scale being balanced. Because you can see with what I've drawn here, there's no imbalance on the scale. It's not that one side's heavier than the other. We have the same amount of marbles on each side. That's what's balancing this. Now, all we want to do is we want to find, well, how many marbles are in this bag? So the number of marbles in the bag, let's call that B. So I'm going to say here, let the number of marbles in the bag be B. So I'm going to assign a pronumeral to this. And in doing so, I'm going to write out an equation. And for some of you who've watched the previous video series, you may think, oh, this is a really easy one. We've done things like this before. But this is just to hopefully give you the intuition about how we can think about equations here. Now, I have my marbles in my bag, B, and I have an extra 1, 2 marbles on my scale. So B plus 2 plus my 2 marbles equals my 5 marbles on the other side. So 1, 2, 3, 4, 5. And I want to figure out, well, how can I find B? Now, in doing so, we want to find out what B is. And we need to find a number that adds to 2 to give me 5. Now, a lot of you may be able to just look at this and go, all right, well, B is going to equal 3 because 3 plus 2 equals 5. But let's just look at this for a minute and let's think that, all right, well, if we were just trying to isolate, get B on its own, well, we would take these two marbles off my scale. So I would erase these two and my scale would get unbalanced, wouldn't it? Because I've taken 2 off my left-hand side, so my right-hand side's going to be heavier. Now, to balance out my right-hand side, well, I want to get rid of 2 marbles here. And that's the act of this opposite operation, guys. If you remember from the previous video series, I'm going to subtract 2 from each side. And that's going to balance my scale now. And this is one of those easy kind of equations we looked at the start of the last series, which we thought of solving by inspection. So if you know how to add, subtract, divide, multiply numbers, you can find these unknowns quite easily. But this analogy, I'm hoping, gives you an idea of the system that we used to get to this in the first place. So let's try another example. And this is going to be another revision example, and then I'm going to take it up a notch to some of the stuff that we're going to be working on in this series. So I have my scale again, and I have on either side, I'm going to change this up a little bit. So I have my scale, and I'm going to say in this question this time, I'm going to have 2 bags of, oh no, let's do 3 bags of marbles. And I'm going to say on my right hand side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles here. And I want to figure out how much is in each bag here in order to balance this scale. I want to find the number of marbles in each bag that's going to make my scale balanced. So I have 3 bags here, and I can write that as, okay, B plus B plus B. So my bag plus another bag equals 9. Now I have, if you remember from arithmetic, what's an easier way to kind of to write this something plus something else? Well, think about how many groups of B, how many groups of my bag do I have? Well, I have 3 lots of my bags, and that equals to 9. Now, all I have to do here is just consider, well, what number multiplies by 3 to give me 9? And in doing so, I can also think of, well, if I want to split, I have 3 bags here. I have 3 equal bags with an equal number of marbles, and they all equal to 9 marbles. So why don't I split my marbles here into groups of 3? And this idea of splitting into groups, well, that you may remember is dividing, right? And so here I have a multiplication. Sorry, let me write this B a little nicer. I can think of this as 3 times B, 3 lots of B. I can find what that is by dividing 9 by 3. I'm doing the opposite operation here. I'm dividing by 3 and I'm dividing by 3. So I have 3 equal bags and I want to find, well, how much is in each bag? So I'm going to divide my amount of marbles into 3 equal groups. And some of you may remember from solving equations by inspection, we can easily do this if we know our times tables. Well, what multiplies by 3 to give me 9? in order to find b? Well, 3 multiplies by 3 to give me 9. Now, this is what we've been all building up to right now. I want to build up to this idea of equations with pronumerals on both sides. This is where it gets tricky and trips out a lot of students. But let's just have a look at one more example, and we're going to talk about this idea a lot more in depth in the next video, where we're going to go through some concrete examples. But here, I'm going to draw my scale again. And I'm going to, up until now, we've been looking at bags and marbles on one side and then just marbles on the other side. Think about this example, this example. I want to look now at when I have bags on both sides. So let's say I have here, I have 2 bags and 2 marbles. And here I have 1 bag, and let's say I have 8 marbles. Oh, let's go 6 marbles. 2, 3, 4, 5, 6. All right. And once again, my scale is perfectly balanced. So whatever I have on the left-hand side is the exact same on the right-hand side. This is this equal idea. My things on the left-hand side of my equal sign are the same as my right-hand side. I just want to find the values of B, or how many marbles in each bag, that are required to make this perfectly balanced. So if I write this as an equation, well, I have 2 bags on the left-hand side, and we learned from the previous example, I can write this as, well, 2 lots of B, and I have an additional 2 marbles, so plus 2, and that equals 1 bag on the right plus another 6 marbles. Now, don't get overwhelmed here. I know it looks crazy because you're like, oh, wait a minute. Now I'm dealing with bags on either side. That's really confusing. But when we think of equations, we're thinking about stripping away our equations. Think about everything we've been doing systematically up until now. We were simplifying the equation, stripping it back till we just got an expression for the unknown pronumeral here as well as here. And in our previous video series, we did this with even crazier equations. Now, this is slightly different, but we think of it in the same kind of way. Because if we wanted to make this scale balanced, if we wanted to strip away at this equation, well, what are we going to strip away to find the amount of marbles in my bag, my B here? Well, I'm just going to start slowly taking things off the scale. So, for example, these 2 marbles on my left-hand side, let me just take those off because that is going to leave me with just my 2 bags. Now, I'm going to get rid of these 2. And in order to balance my scale, I want to do the same thing on the other side. So I'm going to take away 2 marbles here. Now let's look at the mathematical operation we've done here. We have a plus 2 here. We have just done the opposite. We've just taken away 2 from both sides. So what are we left with here? Well, we have 2 lots of my bags here equals my 1 bag as well as 4 extra marbles. Well, now I want to just isolate 1 bag. I want to find what's in 1 bag. Now, how can I do that? Well, if we think about it, the idea that we have the same pronumeral on each side means that there are the same amount of marbles in this bag, and this bag. So if I take a bag off from each scale, that's going to balance it out even more, right? Because I have one extra bag on my left, say this one, and that's going to weigh the same as this one because there are the same amount of marbles in each. So what if I subtract a bag from each? So if I take this one off, for example, I'm going to get another imbalance. How do I fix that imbalance? Well, what I do to one side, I do to the other side. Now let's look at what we've done here. We have subtracted one bag, one lot of B, from both sides. And what I get left with is well, now we need to consider our algebra, right? So I have two lots of B minus one lot of B on the left-hand side, and I have B minus B plus 4 on my right-hand side. Now, 2b minus b, what we remember from algebra, that's just going to give me one lot of b, which just gives me b. And b minus b, this is the same number subtracting from itself. This cancels out to give me 0. So the only thing that's left on my right-hand side is this 4 here, this positive 4. So the amount of marbles in each bag here is going to be 4. So you may look at this and go, wait a minute, like, what's going on? How is that possible? I want to check that that's true. Now, hopefully you follow the actual logic of balancing the scales here. Hopefully the intuition is there. But let's just double check this. And I promise we're going to go into this in a lot more detail here. And in the next video, I should say. But let's just check. So my equation, if I can just copy and, well, let me just drag it down here. Whoops. You may remember from our previous topic that once I get an answer for my equation, a solution to my equation, something that makes the left and the right-hand side true, we can check it by substituting the value of b back into here and here. So 2b, that's like saying 2 times b. So I can substitute this 4 into here, and that gives me 2 times 4 plus 2, which equals to 4 plus 6. 2 times 4 gives me 8, plus 2 gives me 10, and 4 plus 6 gives me 10. So my marbles and bags are balanced. They're perfectly balanced. We found a solution, a number of marbles in each bag that makes the equation true. Now, like I said again, we're going to go through this a lot more in the next video, but this idea of scales and balancing scales hopefully gives you the intuition as to how we can begin to start applying systematic solving of equations to equations with pronumerals on both sides, ones like this thing down here. And you may have noticed that I'm chipping away at it in the same way that I did with my pronumerals on just one side. See, what I'm doing to one side, I'm doing to the other side. I'm still applying all the solving equations systematically ideas from our previous series on equations, but now I'm showing you that, well, not only can we do this with the numbers, we can also do this with the pronumerals. We can take the same ideas, and by applying this scale analogy, hopefully that's convinced you at least slightly that we can treat pronumerals in the same way. But we'll talk about this a lot more in the following video. To those who are still watching, thank you so much for joining me in this video from our new topic, and I will see you in the next one in which we keep going down this path of solving equations with pronumerals on both sides. Thank you so much for watching, guys, and I'll see you in the next one.